Okay, we're going to look at how to calculate the limit of a function by using what we call the substitution method. So you can see this function here. First thing you notice is that you have x plus 8 to the 1/3. And before we even get to that, we can see here why we need to use a limit, because this x right there cannot equal 0. It's going to be undefined. But this right here, I apologize for that. But this right here, this x plus 8 to the exponent 1/3, that's difficult to work with. So what we can do, without changing the function, we can actually rearrange some of the variables just to make it a little bit easier to work with. So I'm going to set that part, that x plus 8 to the 1/3, equal to the variable u. Now, when you're doing this, whatever has that fractional exponent is what you want to set to the variable u. So, if we have another one, if we have x plus 7 to like 1/6, we would set this equal to u because that has this fractional exponent, which can be difficult to work with. So that's your clue. Anytime you have parts of your function that are set to exponents that are rationals or fractions, whatever you'd like to call them, this is a signal that you can use the substitution method. So I'm actually rewriting my limit. So I got my limit. See, now this right here is now u. Minus 2 is just minus 2. So now I can only make that distinction once. So in other words, now I need to rewrite that x in the denominator in terms of u. But I need to go back here, and I need to work this out in order to do that. So I can see there's an x right there, so I want to solve for that x. Now that's not going to be too bad, because I can just multiply this 1/3, raise it to exponent 3, and that'll be 1. That's what I want. I want that a little bit easier to solve for. But again, to make it logical, I need to raise the u to an exponent 3. And now this is much easier to solve for x, and that's what I want. So now x is equal to u cubed minus 8. See, this is going to be much easier to work with than that fractional exponent. Again, you didn't change a function, you just set one part of it equal to a variable, use the common one we use, and then you base that distinction on everything else inside your function. So in other words, after that one statement, you were able to solve for x in terms of that same u. Now, one thing though, it's not a limit as x approaches anymore. It's got to be as u approaches. So you need a new value. So you want to go back to that original u statement. Remember, this was the original statement I made. I let u equal x plus 8 to the 3rd. So now I'm going to take that original 0 that I was trying to approach, and I'm going to sub it in there for x. And this is just going to be 8 to the 3rd, which works out nicely to 2. So again, you always need to go back to that original u statement, and you need to set in that value that x is trying to approach. So now you have your limit of what u is going to approach. So now this right here is going to be much easier to work with. And in fact, I'm looking here, like if I try to sub 2 in there, I would get 2 to the 3, which is 8, subtract 8, which is still 0. So I still got some work to do, but it's going to be much easier to work with. So this is causing a trouble, so something there needs to cancel. So what I'm going to do is actually, I'm looking at that, and I can factor that one. So I can use the difference of cubes there to factor. So u minus 2, u squared, plus 2u plus 4. So I can just make a little note here. Factored using difference of cubes. So now when I do that, again, what you want to do, you want to do something, and you want to see if something can cancel. Just by doing that, I notice that because these are multiplying, they're factors, that those two u minus 2's can cancel. Now remember, that's going to leave you with 1, not 0. So now you should be safe to approach 2 there, and I think we are. 2 squared plus 2 times 2 plus 4. So I believe that's going to work out to 1/12. So again, it is still the original function, but just by setting one portion of it equal to a different variable and rearranging the whole function around that one variable that you used, you were able to dress it up and make it a little bit easier to work with. So again, the clue is anytime you have parts of your function raised to rational exponents, or fractional exponents if you want to call them that. All right, we will see you in the next video.